So I think we're starting now with the piano piece, just, as a during the waiting time to have some entertainment. Stuart?
My name is Ife Ezinmadu, and today I'll be playing Clair Lune by Debussy.
Yeah, wow. Wonderful. Like thanks Ife. He like the pianist is actually here today. We have him live here. Yeah, I mean, I was just really almost crying yesterday in my bed listening and preparing for this event. Thanks so much.
Thank you,
So,
Father.
Ife, can you tell us a bit about yourself? Like, what are what are you doing?
Okay, my name is Ife Ezinmadu, and I'm a pianist from Nigeria, currently studying at the University of Edinburgh in my third year of studies. I think the most popular question I get being asked is, why do you study music? Well, I say I did not choose music. Music chose me, and here I am, just enjoying it and living in it. Yeah.
Like that's it. Yeah, I think you were really chosen by music. It was just wonderful. In terms of, you know, like we talked and we talked what could be the right piece for this event, and you actually decided what kind of a piece to play. So like, what made you think, you know, choosing what you did? And I think it was just a wonderful match.
Yeah, I mean, at first when you asked me which piece, I was really thinking of something virtuous, something like a Rachmaninoff prelude or something, like but I thought about it again, linking it to the theme of the event, relating to African stuff like that. I was like, okay, what was the piece that I remember from home? Because the last concert I gave, I used Lune as my encore in Nigeria in 2018. So I was like, yes, that is the piece I would play. As simple as and basic as it's has a meaning to me, and also in relation to this event relating to Africa. Yeah.
Awesome. Yeah. And like I'm just checking the chat, like everyone is saying that it's just like wonderful what you played, and you know, it was just perfect for this purpose. Like, you know, just for some self-advertising pieces, are you doing that stuff also, you know, for others, like recording songs and sending that?
Yes, absolutely, absolutely. I'll be delighted to do more of these. And I mean, prior to the pandemic, I was playing quite a number of shows for the university, and you would find that in my on my YouTube link, which I've attached in the chat. And I've played about I think 6 events for the uni at the moment, and many more to come. Hopefully, when things open up. So I'm absolutely delighted to share my art with everyone, and all thanks to virtual reality, we're able to do this even as we are in different parts of the world. Yeah.
Absolutely. I think that's some of the cool parts that you can just do it, you know, globally now. All right. I would say, like, thanks, Ife. It was wonderful to have you here. We're now actually starting with the event, and I would just ask Davide to share the slides.
Can you see the slides?
Yes, we can see it, and I'm just requesting remote control. All right, that seems to work. Okay, so starting now with the event straight after the wonderful music from Ife. Yeah, we're talking today, or we're presenting you today, the whole kind of workshop about, or seminar about from Africa to Earth, energy system modeling, where we focus on our prototype of PyPSA-Africa, which we developed quite a while. We're talking about our new initiative, PyPSA meets Earth, and then we also have a small panel discussion. So my name is Max. I'm actually a second year PhD student at the University of Edinburgh. I founded the PyPSA-Africa initiative last year about, and I'm happy to see you know, quite a wide interest, broad interest in the field, and with a lot of support from everyone. And actually right here at the beginning, I also want to thank you, the audience, for supporting and continuously recommending us. I also want to thank you, the whole PyPSA meets Earth team, or PyPSA meets Africa team. Is still a bit like we're identifying us as both now. And yeah, there's a lot of effort in this event and in other parts of the initiative, and like a lot of thanks to all. And then also finally thanks to Tom Brown and the PyPSA group in general, because they actually worked on this PyPSA environment and this open source tool for a couple of years now. And we are just really building up on the efforts and trying to do our best to continue growing this kind of toolkits. He's unfortunately not here today. Next time we manage that. But there's always next time. So I would say we're starting now with the presentation. Okay. Yeah, perfect. I just want to set the scene now. What's the motivation of our activities? So, you know, we see the climate challenges upcoming, and we need to go through a lot of changes. And while going through these changes, there's not only the question of, you know, is our future system stable with all these renewables, but there's also a question of the investments. How should we distribute our power plants? What technology should we focus on? And all this question really impact then how affordable, reliable, and also sustainable the energy system is. So when people usually reach out to us, they ask, okay, what is it what we're doing? What is our initiative about? And I can say now, and that, you know, settled a while ago, we are a global independent research initiative. And independent means here really that we have a budget of 40 million euros. That's a joke, like we have actually a budget of €0 of direct funds. So we're not directly funded by anyone. It's more about we're having funded people and people doing that stuff as a hobby and want to learn things who are joining us. And maybe that funding part, you can change that by, you know, funding particular people or groups who want to join in some part of the initiative, and that obviously helps to make more impact. When we think about the initiative, we actually have 4 blocks of what we are tackling. We work on from the right block on the user and developer community. So we want to become like one of the biggest community in this aspect, to empower people, train people, working collaboratively, staying always in dialogue and being open. In another block, we're also working on data, creating data workflows so that not everyone needs to do that themselves. We're creating open data, we're predicting data, and also work a lot with high resolution data. The third block is about energy system models. And because data is actually not useful, data is worth nothing if you're not using it somehow. So, and with the energy system model, we are focusing on making also this high resolution data useful. And we're working there in different aspects, from features to the problem formulator, which is PyPSA in this case, making everything modular so people can reuse it also maybe for other models, and performances are key there as well. And last but not least, and that's always good to understand in this whole energy system modeling frame, is sometimes you want to analyze a least cost scenario. So when you want to analyze a least cost scenario, there comes optimization into the game. And if you have big problems, actually 99% of your time goes into the solver. So building up a European African energy system model can take 15 minutes with Python, for example. But running it then with a solver, depending on the size of the problem, can take a day or several days. So with the actually fastest commercial solver, which is Gurobi, maybe I'm wrong here, but something like Gurobi. But we are also working on, from the access perspective, on open source solvers and supporting here the development, identifying bottlenecks, and initiate paths that we can also push that forward. So that are really our, let's say, 4 blocks which we're working on. And we're doing that all to have a useful alternative, to work together on a useful alternative for closed source energy system models. And that should be useful then for industry and research. Yeah, and I think that's it. We have now a nice roadmap. I'm really excited about what my colleagues are presenting now. I talked now about the first part, a bit about the initiative of the Earth Initiative. Then Davide will continue with the prototype presentation, and then we go along the line. So Davide, do you want to continue?
Hi, thank you very much. I'm Davide Fioriti from University of Pisa and co-director of the initiative. And today I will introduce about the prototype. PyPSA-Africa is our first release, has been on last December. And for introducing it, I want to start from the problem. What is the problem that we want to face? The problem that we are facing is that Africa is dark. So when we look at this picture by NASA, we can see that the entire continent is dark with respect to the other areas. And if we consider that Africa is way larger than Europe, this is even a very incredible consideration, also considering the large population that lives in it. And this problem is even worsening, if you see, in the sense that if we don't act, the problem will rise, because the current picture of per capita indicators demonstrate that now Africa is has a GDP which is 1/4 with respect to the average global when compared to the population. In fact, the GDP and the energy demand is just 10%, 5% of the entire picture, but its population is roughly 4 times larger. And the population is even growing in the coming 20 years. And even in 20 years, the current forecasts do not lead all the entire population to be electrified. Roughly, there is beyond 500 million people that won't be connected by 2040. And this is a challenge that that planning tools shall face. In fact, for planning a bright future, we strongly believe that planning tools are a must. In fact, obviously, planning tools do not solve everything, because there is need for a lot of resources, credibility, and stability. But we believe that good planning tools can enforce and improve this, and that's why we want to face this. In particular, when we compare our initiative to other models, we can see that our model wants to be a more flexible solution than the standard available tools, that yet they are still able to capture a lot of the nature. But our tool aims to be able to tackle both a large scale resolution like Africa, but also addressing with the same tool, but changing few parameters, a Nigeria case or another group of countries. By doing this, and thanks to the already developed tools such as the PyPSA community, we are able to do so. In particular, when we consider what policymakers and utilities need, which are basically a robust, low-cost, reliable, easy to use, flexible, and tools for planning and dispatch, we can see that there is space for PyPSA-Africa, and our solutions are sketched here. In particular, thanks to the PyPSA group, which is and the tools PyPSA at Light and PyPSA Europe, we can provide a robust tool built on top of these activities. It's going to be open source, which means that it's going to be low cost for all stakeholders involved for energy studies, to develop energy studies. And it's going to be reliable because thanks to the open source, there is ongoing validation by a large community, currently even beyond 60 people already. And after this discussion, even more fully. And we provide, thanks to good visualization and an automated workflow, good scenario analysis with just a better resolution. That is what is needed for developing these studies. And when we go at how it works, how PyPSA-Africa works, this is a sketch about that. Thanks to the already experience by the PyPSA Europe, there is an automated workflow that, starting from simple configuration files, it automatically draws what are the scripts and the elements that need to be developed and running them efficiently, which means that depending on the large number of scenarios that a stakeholder may be interested to develop, let's say load 2030, the scenario 2050, then the specific functions will be executed only once to tackle the specific scenario, going from the configuration file to the data processing till the results. In particular, the data processing is where our initiative is really building a large novelty. And I will go deeper into this. First of all, for having a broad picture, what we mean with data processing means combining different open source data sets, and thanks to our function, they are transformed into an accurate network description, which is basically a network model for the entire continent, and also demand a renewal production by every region. And when we speak about region, we mean shapes, which are flexible and arbitrary, in the sense that depending on what is the scope of the analysis, the shape can be as large as regions or as large as municipalities or provinces to adapt to the scope of the analysis. And every shape is going to be populated with data such as GDP, population, renewable energy sources, demand, and so on, that are going to be the input data for the modeling. But let's go deeper into this and having a broad picture of what are the inputs and the outputs of our activity. We start from the network. The main base network that we have developed is based on the OpenStreetMap, which is a large open source data set with among the most up-to-date data. And as you can see on the left, by simply setting Africa as a configuration file, here countries equal Africa, we can draw this image, which represents the raw data set of OpenStreetMap that is automatically downloaded by the procedure and the workflow. On the right, you can see a comparison with established sources that estimate the current network in Africa, and we can see that there is a quite good overlap, yet to be improved, because as estimated by the activity on the picture on the right, we can see that there is some overlap that is not perfectly matching, such as, for example, in Angola or in the Democratic Republic of Congo, for example. With the same workflow, moreover, we can also study single countries or group of them. And this demonstrates the flexibility of the tool. In fact, by simply specifying countries equal Nigeria, is in this code, we can automatically draw this image that is a good representation of the current network in Nigeria, as also proven by the available data set provided by the transmission system operator and publicly available on their page. We can see that the topology perfectly matches. And obviously, there are going to be planned activities in the future that can be integrated, as well as more refined data can be also included for each specific country. This is all for the network for the moment. But what about the power plants? Power plants, there are plenty of data sets available worldwide. The KARMA, Global Energy Observatory, Global Power Plant Database, OpenStreetMap, and so on. And which data set do we use? The answer is simple, all of them. Thanks to Power Plant Matching, which is a tool available, again, open source, it is possible to combine all these data sets together to provide a refined picture of the entire continent. As you can see, thanks to the Power Plant Matching, we are able to draw this image, and I thank Fabian and the group for also providing the scripts for drafting this image. And we can see that the representation here of the distribution of main power plants across the country. Obviously, having data is not all enough. We need to validate them. That's an open question that we are facing right now, and anyone willing to contribute is welcome. And that's why we started some validation. And when we compare data for the entire continent, we can see that there is quite a good overlap with respect to the available sources, such as by ARENA or IEA. However, there is still space of improvement because we miss around 20% of the capacity. And also, to improve on that, we need the country level validation and also possibly integrate multiple data sets to possibly improve the matching performed by Power Plant Matching. Moreover, as we well know, conventional generators are not everything. We do need also to estimate the renewable production, and we rely on that on the tool Atlight that combines the resource potential, shown as on the left, for example, for temperature, and combining it with the local availability of space, in particular where assets can be installed and when cannot be installed. It is possible to estimate the time series for solar, wind, hydro, and also CSP incoming. And because thanks to our tool, we are able to perform high resolution studies, not only in space, but also in time, because we can have simulations at hourly time resolution. The same applies also for demand, but estimating demand, as Stephen will tell you, is absolutely not easy. There are uncertainties ongoing, as shown here. Forecasts for the next 20, 30 years are pretty uncertain, with gaps even beyond 20, 50% errors. And that's why when we think about the modeling, we need to address them, and we use different models, because for a country or a group of countries, one tool may be better than the others. And our approach is to possibly integrate many tools that perform things better depending on the context. Currently, we are using Global Energy GIS, and we also are developing an initiative to build on the experience on that, and the tool is going to be called Demand Creator, and Stephen will talk about that. And other models, clearly yours. We welcome all contribution, and any model that can be better for a specific task is going to be considered for the integration. So, and if you want to work on that, contact us definitely. What I've talked so far is a large problem that needs to tackle, that needs a large compute, large resources, and a lot of complexity. And we need to dominate the complexity to be able to solve these type of problems. And that's why we have specific functions for clustering data, both in time and space. And here we can show what is the clustering approach performed on space. We can see, for example, that the African region can be clustered arbitrarily into a 420 node, but we can also do it at 10 node resolution or 100. It's just a parameter in the configuration file. And we can draw, and the same applies also for smaller regions, such as Nigeria. And thanks to this reduction of complexity, this model can be run also into your personal computer with lower accuracy, but than a larger network. But this can adapt to the specific need of the stakeholder, which is significantly important. Moreover, when we look at Africa, we can see that there are different power pools and different regions that are isolated. In fact, we can see that the south region is not connected to the north, for example, and this is a well-known thing. But there are ongoing studies about the possibility to interconnect them, as well as off-grid areas. And we developed a network augmentation tool so that we can develop and integrate automatically auxiliary lines that perform and enables a higher connectivity of the network and improve the sharing of resources across the country. And this is very useful also for off-grid areas and energy access studies. And that's going to be another topic of interest. After this, the model is ready to be solved and optimized. And the images shown here are just examples of what can be automatically produced thanks to the initiative, the procedure. In particular, on the right, you do have a 2030 scenario for the entire Africa, but however, data needs validation for every proper scenario. And we are willing to work together on this, create scenarios, develop efficient and good plots to infer decision-making. If you think that's not enough, we totally agree. We are going to move next. And what's next? You may say that there are some limitations or points to tackle. For example, low data accuracy. We focus on larger scale data, and that's why we need to improve on that. But is it a problem? And is it electricity enough or single year model? Yeah, we do have the solution. For the low data accuracy, we are ongoing and we have thought and we are going to implement so-called linkers to use the best source for the specific task. Moreover, all electricity, just today, this morning, with Asem, Leon and Fabian, we discussed, and Max and others, we discussed about the PyPSA-Africa sector coupled version, which inherits from PyPSA Euro sector coupled version the skills to perform a multi-energy system analysis, also considering industry demand. And clearly, the optimization of a power system is a dynamic process, and that's why we consider this and we plan for a pathway optimization to understand how to reach the 2050 from today. And is this the entire picture? No, again. We want to go global. Africa is the beginning, and everything that is going to be applied for Africa will be applied also for the Earth. Because this is the problem that we are facing, and we need your help to achieve this. And because the world and Africa needs to do this fast. And that's why if you are willing to contribute, we are welcoming all the experts for energy, computer science, Python experts, or also institutions and governments for improving and building on this. Contributions are absolutely welcome. I thank you. And I give the floor to Lukas and Stephen to deal with missing data. Please, the floor is yours.
Thank you, Davide. I'm just testing the remote control of the screen, but it should work. I'll be talking about the infrastructure, detecting infrastructure part of the AI. I think I'm just docking to Davide's PC. All right, this looks good. So yeah, I'll be talking about the first part, the infrastructure detection. So since machine learning and object detection has really taken off a few years ago, it's a very intuitive task to detect this electric infrastructure from satellite imagery. So we are not the first people to think about this. So the really seminal work was done by the World Bank in cooperation with Development Seed 2017. And what they were looking at was at individual towers and trying to teach a model to detect these towers on a really large scale. So as you can see right here, you have 4 towers, and 3 out of them are detected by the model. And if you do this on a larger scale, you can really start to see the pattern of the grid emerging. And this is really nice. But on the other hand side, this really takes a lot of manual input. So for instance, to train the model, you have to have a person that goes over a lot of satellite imagery and basically annotates it. So the person has to say whether or not there's a tower, where the tower is, etc. Also, this type of satellite imagery is very costly. And this is why after that, people have started to think about a more approximate version that can be scaled better. So again, cooperation between World Bank, this time with Facebook, and they were looking at a much more coarse-grained version of satellite imagery, in particular looking at nighttime lights. And using these lights, they were able to infer the most likely structure of the grid. And this led to gridfinder.org, which is a really amazing website where you can see an approximation to the global electric infrastructure. So it's really cool. However, knowing the individual coordinates of towers is, of course, more useful than having only this approximate version. So what we are basically doing is to re-tackle the problem of detecting individual towers using 3 developments that have really only taken place in the last 1 or 2 years. So the first one is about data. There was a data set released by Duke University, which contains more than 10,000 towers, and all of them are really manually nicely annotated. So it's perfect to train your neural network on it. Then on the other hand side, there's satellite imagery, high quality satellite imagery released by Baxab for humanitarian purposes. Now, this imagery is not particularly concerned with the electric grid, so it's not annotated in any way, but it allows us to test whether or not we can have models that are trained on the upper data set of Duke University and perform on the Maxa data. And this transfer of learning performance is highly non-trivial, and for it we are using recent advances in machine learning. So people are very interested right now in training a model in one context. So you might teach the model to detect people on a beach, and then you want, without additional manual input, transfer that learning performance to another context. So that might be a beach in the evening or something like this, such that the model can detect people in that context as well. And this is exactly the method that we are employing here. And the ultimate goal of this is to have a full pipeline in which you can feed a satellite image, and it's basically going to give you a table of all coordinates of all towers or other parts of the infrastructure in that image. So this is a task that is varyingly difficult for different kinds of architecture, of course. So the larger the tower, the easier it is. The smaller the tower, the harder it is, but also the more valuable it is. And so, of course, we are starting with the easiest version and moving forward to the harder tasks. But for all of them, it's non-trivial. So we also welcome support from people that are experienced in coding, machine learning, data, these types of things. Of course, need resources, computation, data storage, these types of things. And if you happen to know something about this on a high level, even from NGOs, governmental entities, project developers, we of course always welcome the support. And with this, I'm going to hand it over to Stephen, sorry.
Thanks. So yeah, my name is Stephen Lee. I'm a PhD candidate at MIT, and I'm the demands lead for the PyPSA community. And I'm honored to be speaking with you all today. Electricity demand forecasting is actually my thesis topic, specifically focused in Africa and South Asia. And it's incredibly important. A lot of studies have shown this, but it's actually pretty obvious. If you get demand wrong, you're going to plan your infrastructure pretty incorrectly, and especially where there's scarce resources, like in the settings that we're talking about. This could be extremely delayed progress, for instance, in reaching our combined goals. And maybe a little bit different from what Lukas presented, demand can't be seen, at least not directly from the sky. How would you do that? And that's exactly what we're trying to solve and with our community. So I'm going to be open sourcing, and I'm actually going to jump to the next slide. Davide, oh, I'm good. So I'll be open sourcing my published research as part of PyPSA and opening it up for collaboration. And fortunately and unfortunately, through my time thinking about this topic for several years, I have more questions than answers. So I think this space is really ripe for collaboration and really making a lot of impact, especially by thinking about demand and looking at demand. And specifically, our team working together to build open source data pipelines and build different models for baselining and comparisons across 3 different activities that are shown here. So there's 1, country level demand forecasting, 2, data-driven downscaling, and 3, building level demand forecasting. And I think we're all familiar here. There's this data that's available at different scales. So there's country level data, which is pretty amenable to country level demand forecasting. But then there's also a whole wealth of high resolution data types, and that's actually exploding and growing now. And I think that makes this a really exciting place to spend time on. And one way to connect the two are using data-driven downscaling techniques that we'll talk about. All 3 are currently under progress, and we need help kind of building this whole pipeline out in a way that's more rigorous, I think, than what people have done before. And from this building level demand forecast framework, you can aggregate and kind of fit to any of those scales that Davide mentioned in the earlier part of the talk. And that's something that we're very excited about. So here, I'm going to be just quickly outlining country level demand forecasting and some efforts that we currently have with Bayesian deep learning, but then there's lots of other methods that are appropriate as well. And I think the most important thing to stress here is that we're really relying on a data-driven approach that focuses on rigorous backtesting. So this is exactly what financiers do with their algorithmic trading. Really what you would want to do to have a lot of faith in your models. There's different types of modeling, of course. We think working with an inductive approach and this backtesting approach, well, at least gives you the confidence that if the future is anything like the past, then we think we can be pretty accurate with our models. So what we're seeing on the screen here is on the left-hand side, country level data, and there's a bunch of different features available with different sparsities across countries of the world. And we're building models that really understand what missing data is and works in kind of these unstructured or structured, but maybe unconventional data sparse environments that you wouldn't see in maybe a very simple machine learning model. We're also hosting a competition. So, and this kind of lends itself to the images on the right, where with this backtesting framework, we forecast in the future and we compare models and their uncertainty estimates. So you might notice here what's actually being shown in these blue fans, if you will, are probabilistic forecasts where there's actually a distribution over future demand evolution at the country level. And this lends itself into the next slide. So downscaling, once we kind of have these country level forecasts and we're as confident as we can be about them, how do we actually distribute those kind of contributions to consumption or demand across higher resolution cells or areas, or even buildings? So on the right, we have OpenStreetMap's images and actually this open buildings data set from Google that's actually fantastic, just absolutely fantastic, really changes our field. And we have models that do this downscaling rather. And it's not immediately always obvious for how to do this, but there are ways. And this is an active area of research for our team. And lastly, well, almost lastly, sorry, number 3, we're doing building level demand forecasting. So we actually have lots and lots of inputs at more spatially resolved areas. satellite images, nighttime lights images, building locations, building densities, understandings of where there's agriculture and where there isn't. And we want to produce maps like this. So this is illustrative, but if the idea is that if you were to click on a given cell or building actually, so you can maybe see a mouse cursor there, you would want to see actually the forecasted demand with some uncertainty, just because you can't be fully certain everywhere. And with this sort of picture, we just enable so many planning tasks and efficiencies kind of downstream. So this is what we're working towards, and we have prototypes to get there currently. And so what are we looking for in the demand team? There's a whole list of possible backgrounds. I won't name all of them, but not just data scientists and developers, although those are critically important, but also things like agricultural experts, policy analysts, people who will kind of infuse this additional element into just the purely technical work that I was showing, and in collaborations and so on and so forth. So please reach out, and thanks for your time. I'll now hand the mic over.
All right, thank you very much, Stephen.
Thank you.
I will see where I can get the control. All right. It's not yet working. Oh, no, it is. All right. Something happened. There we go. All right. So, as my colleagues already stated, we are very excited to invite you to join our team. We are a bunch of people. We are over 16 members right now, and we're going to become a lot more. So we have very diverse backgrounds. We have 26 coders, obviously. That's the core of our operations. But we also have 27 advisors. We have 9 people as communicators on our outreach team, 14 PhD students, a lot of students, postdocs, scientists, 13 energy professionals, and 9 professors. And we're associated to many different universities, research facilities, companies, consultancies. So whatever your background, if you're joining us today right here, we are pretty sure that you will be a great fit for our project. So why do people actually join us? I mean, obviously, we all want to create an impact. A lot of us actually want to solve our own energy problems. So we have research institutes joining us that are looking for a very good open source model because they just believe in the concept of open source. Then, of course, if you're a student, if you're a PhD student, and you want to learn and just apply methods, it's basically a playground. This is what we're doing here. We're just building this. We are independent, so we can try stuff out. And obviously, working together in a very nice and international and interdisciplinary team is just a lot of fun. So yes, what is your motivation to join us? So whatever it is, make sure to reach out. And how do people join us? I mean, obviously, for most of us, it's a side project. It's a hobby, as Max said in the beginning. But a lot of us also feel like this tool we're creating might be useful for our work. And something that we are looking into right now is to basically fund dedicated positions in our project to take it even further. So I think our coders already mentioned or had their wish lists, but we would like to just wrap this up a little. So our wish list, or what we need to continue with our work to take PyPSA meets Africa to PyPSA meets Earth. Any contribution regarding new open data and methods is highly welcome. If you're working in this field, if you're interested in this, please join us. If you are looking into expanding and maybe even validating the model to your own region, which is what we're doing with the expansion of PyPSA Meets Africa to PyPSA Meets Earth, then absolutely join us. From our experience, it takes a couple of months, 3 months, to actually have like a model that's ready to run for your region. So that's some exciting work for you. And obviously, if you have any ideas, any research ideas you would like to share with us, or you think might be a good fit with our project, then you're very welcome to participate. Yes, and then obviously all the points that were mentioned before, if you want to join our open data campaign, if you want to join our code team, even if you want to join our outreach team, you can join, and if you're really into it, you might lead it at some point. Which leads me to the open source ladder. We had a question already in the chat on YouTube, and someone feels like you would like to contribute, but needs to understand the project a bit better. So this is the first step. Yes, join us. It can be a bit overwhelming in the beginning, but it's a really nice project. If you get to understand it, you start using the tool, you participate, you can eventually improve it, and at some point, depending on how dedicated you are, you might end up leading, because we're pretty open for like any ideas, and if you want to take responsibility, we're pretty sure we can give you a work package so that you can lead one of our sub-projects. So yes, this is a short insight, and it would be fantastic if you would join us after this event. And I would like to hand over to Lukas and Davide. I think we already received a lot of great questions in the Q&A.
Thank you, Lukas, Stuart, for your interesting presentation and all the previous presenters. And I invite you, all the audience, for any question may arise and you may have. We see a lot of questions already, and let's see. A lot of thank you. If you have, Herakli, you do have a question, you can easily, maybe I can. So this. GIS maps are not very helpful when analyzing meshed networks in small regions. Do you support building in not geographically bounded representation of the network? So this maybe is a question more related to the network representation. I think currently when we look at the small regions, is going to be, so currently we are focusing on the transmission level, but we plan to go at the distribution level, because your point is absolutely right in the sense that when we go in small regions, the representation of the network is more complex, and that's why we need special tasks and improvements on this point, in these parts. We discussed about initiative for distribution levels. There are, and that's something that we are building on. And if you have any insights, you are welcome to address absolutely.
Thank you. With this, I'm going to take a question from the raised hands. So please, Mubashir Hossain, I saw that hand for a bit. Ask away. Maybe it has.
I
enabled you speaking.
Person,
yeah.
Sorry?
You have to
enabled
unmute the person. Yeah.
Yeah, I tried this. Otherwise, I think I will just, before we fix this, I'll take a question from the chat. So, does a user need to know Python to use your models? There's a question by Carla Canone. And hoping that I pronounced this correctly, I would answer that I think Python is the most, by far the most useful language that you can have experience in to get to know the model and get working in it. Actually, I don't really know. I mean, JavaScript would be the second one, because in the future we will probably deal with a lot of data, and how that is being managed between servers is, of course, done by JavaScript, and a lot of the visual aspects are handled by that as well. However, still, if you really want to work with the data, with models, it's going to be Python what is most useful by far. Yeah.
Awesome. As Mohammad, I enable Mobashir. Are you here? I enable your audios. If you are here, you can unmute yourself. Otherwise, I ask Mohammad to ask the questions. We see the raised hand.
Hi, can you hear me?
Yep, please.
Okay. Thank you for the opportunity that you gave me to ask my question, and thank you for the amazing presentation and the amazing work that you're doing, because the milestones are so clear and so interesting. I have a question regarding the economic modeling side of the story that is always meets with the energy modeling community. And I'm not speaking about in-depth economic modeling, but something that can give some insight about the demand projection. For example, when you're speaking about a very long time horizon, the impact of the economic activities on the demand projection, or other impact assessments that the energy models lonely are not able to see them, like what is the impact on the land use, or what is the impact of like extracting more water or using more water, or these kind of things that energy models are not able to see, but economic models may help a little bit to have some estimations.
Absolutely, there are. So I give a first answer, then I give the floor to Stephen, who is his main task. What you are saying, I'm not sure if your background is in any economics. Otherwise,
yeah, I'm an energy economic modeler.
Awesome. We could even speak later, because there were ideas about doing some interactions about that. So I invite you also to speak later with you. And now I invite Stephen to answer your question, since it's mainly related. Please.
Yeah. So I actually am a part-time economist. I have a degree in economics. So I can maybe speak a little bit to this, but you're right in that observing, we definitely, at least in the demand side of things, have a machine learning bent to our work. And again, the reason for that is, we really want a back testing framework that we perform well on, that if you can do well on historical data, you can perform well in the future. Economic models are really great at providing scenarios, perhaps, given different inputs that you can tune by hand and kind of project outwards. And I think overall, sort of, at least my philosophy, and I don't want to speak for everyone, because we want to have a diverse community, is that these are actually potentially very complementary models. So, starting with machine learning perhaps as kind of a foundation, and then changing parameters with more economic modeling, which is more really deductive. So it's really this kind of interplay between inductive and deductive approaches. Machine learning is more building a model from data, and economics is kind of constructing a model with economic theory and deducing downwards. I think they can meet perfectly in the middle, and can be a really powerful combination. Would really encourage you to join and continue the conversation with us.
Yeah, of course. Thank you for the clear answer.
Absolutely.
So I think I will, sorry?
Features like GDP and population, and we look at population growth scenarios as well. But thank you.
So I think I will take one more question here. For all the questions that have been asked, they will still be answered. But after that question, we would move to the panel. Questions that are asked in the chat will be answered during the panel in the chat. And there's a second Q&A after the panel as well. So no question will be missed at the end. So Benjamin Boutois, what is your question?
Thanks. I'm actually also working as a PhD student in modeling and energy system investments. And I was wondering, because I heard a lot about your forecasting methods, how do you actually deal with uncertainties in case all your probabilistic models are well, not exact? If you have a probabilistic demand forecast, for example, and then it turns out the demand will actually be different, you might end up with a system that is quite out of place. So do you also plan to include something for robust solutions, let's say, that to make investments or build a system that can deal with a variety of input factors. So yeah, if the demand is higher than expected, then the system will still be good, maybe not great, but good, and will not fail. If you know what I mean?
Oh yeah, I think you're speaking our language perfectly. Davide can probably speak more to it, but we're exactly trying to characterize forecast uncertainty, and really our demand models are penalized for being too certain when they should be uncertain, and too uncertain when they should be certain. And trying to have very well calibrated models is a challenge, but actually part of our endeavors. And then you're so right in that, you know, using those probabilistic representations in decision making is incredibly powerful. If you don't do it, you can really hurt yourself in some rare but, you know, likely to happen scenarios. And actually maybe not even that rare, because we don't have great certainty in much of the continent. But I'll let maybe Davide speak to it, or Max.
Thank you, Stephen. You are perfectly right. Uncertainties play a big role in the scenarios. That's why we expect to draw a scenario analysis. Thanks to the tool already, it is possible to develop different scenarios, and we are planning to do this, so to incorporate the planning and to draft different schemes to different scenarios. Moreover, we expect to go beyond, because stochastic optimization will be welcome, but clearly the problem is already very large, and that's a step beyond that. We have been discussing about that, but it's an unexpected development, but it's on the pipeline. We thought about that, and if you are willing to contribute, you're welcome, and we can see how to manage this.
Yeah, thanks for your answers. Yeah, what I was actually thinking about was also, you know, methodologies like exploratory modeling, to actually try to really, well, it would be a high number of scenarios, or just to see what kind of how the system would perform under different assumptions, and then see what would be a solid choice. But yeah, it would be fun to have a more detailed exchange at some point. But yeah, thanks for the
welcome.
Quick answers, and I look forward to talking with you in the future. Thanks.
Welcome.
Thank you all for the questions. Again, for the questions will be answered in the chat, but now we will move to the panel discussion, and for this I would hand it over to Max.
Yeah, then let's move on here. I think, Davide, you can move to the next slide to see the panelists. Maybe we should also ask the panelists to unmute themselves just to test everything. Clayton, Sami, are you here, and Jared?
Yes, I'm here.
And Jared, does it work in your case as well? Okay, like we cannot hear you yet, Jared, but I'm just introducing the panel and what is the panel about, and in the meantime, maybe you solve the issues. So what is the panel about? You see the headline. It's about energy system modeling challenges and opportunities of the 21st century. And we're actually going along 3 themes today. I call that USA. It's about usefulness. So what exists and what is required to make better decisions. Then the second point is speed of innovation. How do we get there to, you know, fast to better decision much quicker? And then also the adaptation point. How can we increase the amount of better decisions so that everyone has the capability to apply that? And in this sense, I just want to welcome our 3 experts in the field, both in operational and investment planning, also in closed and open source area. And as the first panelist, I just want to introduce Sami. Sami is Senior Program Officer and is in the field of power sector investment and planning at the at IRENA. So Sami, can you just introduce yourself in terms of what you're doing at IRENA, and then, you know, how's your day-to-day job, so that the audience knows who you are?
Thank you, Max, and thank you very much for the presentation. It was really amazing, and I'm always amazed what data science can do. It was not possible before. Now all these things are possible. So it's very amazing to see all this progress. So I would like to just say where I'm coming from, because I'm not actually representing research community, and that actually is quite important to define my intervention. So IRENA, we support our member countries, government with energy planning. And we develop, and we develop models, and we develop tools, we develop data, and we provide them for them to be able to better do the energy planning using modeling tools. We also provide training. We provide small training sessions, but we also provide multi-year capacity building program. And this is mainly focusing on Africa. So that includes training with modeling tools to local expert teams, and we support the development of national and regional master plans by the local expert teams. And just as an example, we recently started to work with the African Union to develop the African Continental Power System Master Plan. IRENA has been selected as the modeling partner in the process, and our modeling tool has been selected as the official modeling tool for the Continental Master Plan process. And in this process, we are going to organize a number of training sessions to the African Union Development Agency and power pool staff. We also have been working with the government of Cameroon, the staff of the utilities and ministries of the government of the Cameroon over the last 1 year. Last year, we also had 9 months of training session with the Central African Power Pool. So they all aim to build local planning capacity, local sustainable planning capacity using different modeling tools. And as IRENA, of course, we would help them to represent renewable energy as best as possible. We are not pushing for renewable energy per se, but we help them to represent that at its best capacity. Another line of work that I'm probably based most of my intervention today is the network of the government planning practitioners. So the network is called Long-Term Energy Scenarios for Clean Energy Transition Network. As a short name, we call it LTES network. Currently, we have 25 countries and 13 institutions as members. And out of 25 countries, 12 is European countries, 7 is from Latin America, 4 is Asia and Middle East. So it's quite diverse, and it's not like the capacity building, but it's more of the peer-to-peer learning opportunity for countries who has been using scenarios for energy planning as a basis of energy planning. And some countries are actually using models within the government sector to develop scenarios. Other countries are not using models per se, but externally outsourcing the modeling capability to develop government scenarios. So we have been organizing these dialogue sessions within the members of LTES, and the focus has been not just like energy models, but to discuss the challenges with the clean energy transition and how these clean energy transition features can be represented in the energy modeling, in the scenarios, and also in the process of developing and using scenarios. So I am representing this community, which is a bit different from the research community. So I hope that I can make a good contribution to the discussion from a bit different perspective. Thank you.
Of course. Thank you, Sami. So that was an awesome introduction. So I think we see now where Sami's coming from where her perspective is coming from. So as a second panelist, I want to introduce Jared. who actually did a fantastic job roughly, I think, 6 months ago. So many of you know him already. But Jared, can you still please introduce yourself briefly and tell us what your, where your perspective is coming from?
Can you hear me?
Yes, we can hear you.
There we go. Apologies for that and some of the logistical issues of working in virtual platforms, I suppose. I'm going to also just start my video so you can see, I hope. There we go. Can you see me? I hope.
Yes, we can see you.
Great. Yeah, apologies for that, and also joined a little bit late, but it's just great to see where I guess PyPSA Meets Africa has gone towards and where it's come from. I was lucky enough to be involved from some of the beginnings as to where it started, and obviously now going towards PyPSA Earth and what that could become. In terms of my background, I was actually based at one of the state-owned research institutions in South Africa called the CSIR, Council for Scientific and Industrial Research. I departed from CSIR in August of last year, and I'll be joining NREL this year in 2022. Hopefully actually carrying on and doing very similar types of work in terms of grid planning and analysis, developing tools and modeling frameworks to assist in understanding both the power system capacity expansion from a generation perspective, as well as, of course, the transmission that's necessary to enable that, especially if we're going to be moving towards more and more variable renewable energy resources. In terms of the work that I did whilst at CSIR, a lot of the tools that were being utilized were very much commercially trusted tools, so to speak, so the likes of Plexos and others. And those are also very highly trusted by policymakers in the South African context and South African environment. The intention, of course, being that if you would like to shift away from that and move towards open source models, utilizing the likes of PyPSA and many others that are available out there, either focusing on power system or starting to think about sector coupling aspects, you need to start to really benchmarking them against what policymakers trust at the moment, and then thinking of ways in which you can then establish that linkage and the trust, and then move away from the commercial tool. Not necessarily saying that you have to throw it out, but it's actually good to benchmark in the long run as well. If you do have that tool running in parallel, but it's probably better to shift towards moving that hurdle away, using open source and freely available tools, making sure that, of course, the data that informs that is as much as possible as good as the data that's informing some of those commercial tools and the exercises that are informing national planning, which in the context of South Africa is quite prescriptive. So I guess I'll pause there for now, but just wanted to say I'm looking forward to continuing to contribute to PyPSA, maybe even benchmarking the South Africa component or maybe the Southern Africa component of PyPSA-Africa over the coming months. It'll depend on my responsibilities at NREL, which we'll see over the next 1 or 2 months as I'll be starting next week. But I really am excited to see what has become of the starting point that was PyPSA-Africa and now PyPSA Earth, and what can happen next. So yeah, thanks for the introduction and looking forward to the discussion and questions.
Thanks, Jared. So I think with you, we have a kind of open source advocate when you need to put you in a class. And then we have finally, last but not least, Clayton. So Clayton, you work as a senior researcher at NREL. You're also the technical co-lead of the Open Data and Tools Pillar at the Global Power System Transformation Consortium. So also, to introduce you to the audience, what is your job in both of these activities, and where you're coming from? Can you introduce yourself?
Yeah, thank you. Thank you for inviting me, and I'm really pleased to be here and really enjoyed the first presentations and excited to see where PyPSA is headed. At NREL, I am principally a model developer. I do use those models for various applications around the world as well, but over the last decade, while I've been at NREL, I've contributed to the development of several tools, ranging from capacity expansion tools through the usage of various approaches to using commercial tools like Plexos and others, And then more recently, I've led the development of a new suite of open source power systems modeling tools under an umbrella called the Scalable Integrated Infrastructure Planning Initiative. And those tools are really targeted at a range of activities from production cost modeling with unit commitment, economic dispatch, and sequential problems down through dynamic stability analysis as well. And we have some prototypes to address some capacity expansion modeling challenges too, but that has not been our focus. Those tools are all available in the Julia language with powersimulations.jl, powersystems.jl, and a few others. So if you're interested, go check them out, or please reach out and I can connect you. And a lot of that activity is all, through the development of open source tools has led me to contribute to the GPST consortium, the Global Power Systems Transformation Consortium, and really try to help lead the effort of connecting open source tools with the power system operators around the world. And so I've been helping with the actual leads. I'm just kind of a co-lead or an underling, but the actual leads are from VTT with Hanale Holtonen and Juha Kiviroma. And we are trying to help identify the best in class or the most useful open source tools for a variety of activities that might be undertaken at power system operator organizations. And so through that, we have some tool portals where we're collecting meta information about open source tools and doing a number of other activities and benchmark. One of them is benchmarking, where Max and I, along with a few others, are trying to benchmark a number of tools on some standard problems, and then also try to coordinate those same set of tools on different problems so that we can create a coordinated workflow across a number of open source tools. And so those are some cool webinars that we are forming through those activities, and those should be available in the coming months. And I'm really looking forward to Jared joining us at NREL, and I'll do my best in whatever influence I can have to keep him involved with the PyPSA community. So,
like, awesome! This is already perfect. Perfect start, Clayton. All right, I think we have now a good idea of where these different panelists are coming from. Clayton, you have definitely a lot of modeling experience as well, and creating such tools. So that perspective is also here on board. So I just want to start with the usefulness point, the U of the USA. So starting with the first question, particular for Jared and Asami, you're being involved in kind of national expansion plans. So what do use of these tools need for the expansion?
Was that up to someone in particular?
Yeah, like Jared or Asami, maybe someone wants to speak out. Whoever goes first.
Shall I start then?
Yeah, please.
Okay, so I actually wanted to say that this usefulness issue is really interesting issue, because usefulness is different for different purposes, right? So usefulness for the student, usefulness for researcher may not be the same as usefulness for the government sector planners. And as I mentioned, in the LTS network, we have government researchers sometimes that they use models themselves, and other type of government researchers, they do work with external scenario planners. Sorry, external modeling experts. So it's really all quite different from the way how the government sector are using energy modeling. But what's quite common is that what they really value is the easy to use interface and easy to understand the logic, easy to handle. So there was a question whether one needed to know Python code to use certain model. And I think it's hard to expect that government sector can use model or develop model directly writing the code, but they would need certain user interface that allows them to easily access the information and create the model and create scenarios. So that's one thing. And it's also difficult to find the right level of complexity. So it's, but maybe I can comment on that maybe later.
Like maybe Jared, do you have there straight away some kind of comments to that? Like, what is your perspective on that?
Thank you.
Okay.
I was on mute and my video was there, so I was just trying to say that I was on mute and couldn't unmute.
So you're no co-host, so that should be solved.
Excellent. Good. Yeah, I think just to resonate exactly with what Asami was saying, the usefulness in models, specifically, at least from what I've seen here in South Africa, is really around the ease of which to interface with the model. So if it's graphical user interfaces, or if it's automated processes to get things going quickly, once you've established scenarios from your principles in terms of planning, actually running them is the easy part. But getting all the data together, getting all the scenarios established, and then running them, the first part of that is really something that needs to be, as much as possible, easy to do. And I don't necessarily think that data handling, the data management that sits behind that has been as easy as it could be. That's quite a challenge. I think we might talk about it a bit later, but really, as much as possible, making all the data available in an open format, maybe consistently open and periodically updated, would assist in that. Because what we find is, for example, we have a periodic planning process that takes 2 to 3 years, perhaps 4 to 5 years or more. Once you get to the point at which you're starting that process again, it can take 12 months to 18 months just to get all of that information again updated, interacting with all of the relevant data sources and institutions, rightly or wrongly. And that doesn't necessarily improve in terms of efficiency, the way in which energy modeling is done. And just to add to that then, in terms of the final part of this, is really trying to, as much as possible, increase the circle of competence of an entire country's energy planning environment. And that goes all the way from academia, from students to staff, all the way towards policymakers in terms of the actual decisions that are being made, is critically important, because it doesn't necessarily help to have a very small pool of very competent and capable individuals when you need to be deciding on such critical topics like capacity expansion planning and transition planning. I think this is very applicable in South Africa, and I'll just resonate with that again, in that we're coming from a very coal-dominated energy mix, and one in which there is plans, or there are plans to diversify away from that, and perhaps even aggressively move towards a more renewable energy mix. But the transition dynamics that underlie that become a very difficult political challenge to solve. And if you can remove the technical challenges, the political ones are the difficult ones. Once you have open data and open source tools and people that are capable of running those, it really starts to reduce those barriers and remove those hurdles quite easily. I'll pause there for now.
Great, yeah. Great, Jared. And then maybe Clayton, like your perspective on the usability factor. Like, yeah, can we make this models easier to use? Or
well, I think ease of use is one aspect, and there's certainly opportunities there to improve and challenges that that come up. But I want to focus on an area that, you know, I agree with everything that Jared and Asami have said, but I want to focus on an area that's a little bit more that comes from some recent experiences we've had at NREL in applying some planning models. So we've recently had the opportunity to work with a few different planning, you know, folks that are actually planning systems and help advise them in their transition to greater usage of renewable energy. up to 100% in some cases. And one of the things that's really come out is in the as we've served results that come out of some of the planning models, the groups that are taking them in are often saying, this is not a system that we can operate, or in some cases this is not a system that we can operate, and so we have to go back and revise those plans so that they can believe in the operation, and we can get down to the level of detail that builds the confidence that the results are something that's truly operable or something that's truly feasible. And so I think there's a really, and that makes a case for an often nitpicked area of our research of like, are we getting into too much detail with some of these models? And I think the answer is not usually. In some cases, yes, you might not care about the particular transmission line parameters of a 50-year planning horizon, but in the case of trying to convince a system operator that they're going to be able to operate a system that might come out of one of these models, we need to have tools that develop those engineering level details and build that sort of trust in the highly detailed stability and highly physical representative models. And so I think there's an area there that's very important of increasing the model fidelity for the case of building confidence and knowing that this is a possible future and not the future, but it's a possible future that could be operated. And
like, just to interrupt you here, Clayton, like we talked before, and actually you also mentioned this point of do we need this complexity every time? To what degree? Like, where is it necessary? So which kind of, like, where do you see is complexity most necessary, in which parts, and where maybe not?
I don't think it's always, there's a lot of use in some model simplifications, and there's a lot of value in broad strokes analysis that I think makes a lot of sense for all the reasons that most of us understand in terms of computational complexity and data availability and all the things. But there are cases where, maybe more regional analysis in some cases where the problem scope isn't quite as large and things like that, or working with a particular planning authority, whether it's a balancing region or a system operator or whatever you might want to call it, where until we can, there's a lot of mistrust in the automated planning tools like PyPSA and Reeds and some of the others in the results that they produce. And so as modelers, in some cases, it's our job to increase the fidelity and the detail to the point where we can build that trust with transparent and open solutions, in my opinion. But mostly so that we can say, this is a study or an operational scenario that you might encounter with a system like this, and hopefully we can plan it so that it is indeed stable and reliable and meets all the metrics of the standards.
Awesome. Like, I think that's like critical points in terms of where should we go, that this decisions or this suggestions from these tools are really being adapted. So I think we had here like three different kind of interesting perspectives. Like Asami, you talked about this usefulness part. Jared as well, you built on top of that, you mentioned some kind of open source part and parts, and Clayton, you talked about this mistrust in these tools because of this aggregation and increasing complexity, which might be helpful to build this trust. So the question is, so I think we have some couple of challenges there in terms of the usefulness. How do we get there fast? How do we solve all these problems? Is there, what role plays the developer community or the user community in this part? Just maybe continuing here, Clayton, what's your perspective here?
I think the open source community is so this is one of the goals of GPST, is like these are needed things, and the transition is occurring, but the solutions are not there yet in many cases, and so through the open source pillar on the GPST, we're hoping to bring together communities where we can take contributions from a variety of angles and build modular tools that can address these challenges. And I think PyPSA has done a good job of, PyPSA and some of the other flagship tools like Panda Power and, to some extent Map Power and some of the LF energy tools have done an excellent job of creating modularity that's often not available, and modularity and flexibility that's often not available in the commercial solutions. And so I think there are lots of opportunities in the open source to really accelerate those capabilities and be able to deliver the planning and other aspects of planning and operating systems, the tools that can support that.
Okay, that's interesting. Like you're focused here on the open source part.
Yeah,
I understand why. But maybe Jared, I think you work with you have experience with both sides. So is there? I mean, commercial tools. Everyone can create features, and commercial tools or closed source tools can also address them. But what is your experience in terms of, let's say, flexibility or speed of innovation that can be adapted in both of these worlds?
Yeah, I mean, well, I guess just the direct experience now with PyPSA in the space of 6 months is already a prototype out. I don't think the conceptualization of a lot of commercial tools and then the initial releases were in any time frame close to that, to be honest. So at the same time, though, I do think that there are commercial tools that are very strong in particular areas, and learning from those in terms of bringing those across into open source tools is something that I think the community could definitely, I guess, scale up on. But at the same time, considering the importance of the topic that we're discussing now, which is sort of the energy system modeling challenges that we have, and I know we're sort of very proud that there's a lot of people attending. There's only 120 or 180 or 200 people attending when it's such a massive discussion globally as to how do we address the way in which we produce and consume energy, moving towards cleaner ways in which we do that. But we need to scale up that effort. And it doesn't necessarily mean it needs to sit within commercial enterprises to then develop models to solve these types of problems. It seems pretty clear to me, so far at least, that the open tools and the open modeling frameworks that are being developed are already doing a pretty good job in certain areas and a better job in certain areas, but then are a bit deficient in other areas. So if we could really scale up that community, I think then there will be a lot more speed. And scaling up that community does necessarily mean, in a lot of contexts, the funding that goes with that, but with a bit of a different, or maybe a very different type of approach in terms of the business model that goes with that. Because it's not necessarily about establishing a business that services just the development of the tool, but it's all the services that sit around that and the data that supports it that might become even more important into the future.
Like, that's interesting. It's also like from our perspective, I mean, there are so many things to tackle. Like it's really, like we could create so many different working groups and different aspects going in much more detail. And it's even not in, let's say, more mature models and perhaps Europe and so on. There are also these challenges, and like we need to tackle them. And in this regard, in this context, what about like we see a current growth of different tools. Every institution has, for example, their own open source tool. Question maybe to Clayton before we go to Sami. Like, what is or whoever has thoughts on that? Is this growing growing amount of open source tools also worrying in terms of collaboration perspective?
So I think it's it's encouraging in that there's a lot of people interested in this space. It's all I think it's an artifact of the lack of maturity of the space in a lot of cases. So, as every grad student over the last 15 years has written their own unit commitment solver or unit commitment model to develop, to start answering questions of how does wind contribute to the power system operate. Like it's just, and that's been, in my experience, that was because there was nothing readily available that I could make use of in my research. And I think we're starting to see cases where the maturity of various tools are getting to the point where students can make use of them and build upon them rather than starting from scratch and build their own parallel approach. And so there are, examples of Panda Power, Power Models.jl, hopefully some of the ones that we've built in power simulations and things, where you're starting to get a level of maturity and a level of quality. PyPSA is a good example, where people can build on them and they're modular and flexible and transparent enough that you can build on them rather than starting over. And so I think we're going to start to see in certain areas some collection around those flagship tools, but I think there's a double edge to that. So both encouraging and a comment to the quality or the level of maturity of our field.
But comes to also like a challenge in terms of how to collaborate with it. I mean, it's, like we feel also, collaboration actually takes a bit of your capacity.
Yes.
And then we actually work together in one of these collaborative actions. And like, how can we improve that in future? Do you see any kind of perfect solution to that?
I mean, I think that these model comparisons and benchmarking efforts are fantastic venues for that, where you understand, you come together and understand what the differences of different approaches are, learn workflow techniques, align on interfaces. One of the things that we're doing, Max, is we're passing data from PyPSA into several other tools. And so how do we do that? Can we agree on common standards? And those are like the most, those are the low-hanging fruit. Like if we can have a common data standard, then we can pass data back and forth and use several tools on the same data. That's so valuable. And so building those communities that way, I think has been my approach so far. And I think that we can get a long ways there. And yeah. So.
Perfect. All right. And then like moving also a bit to this adaptation part, I think we have now about 7 minutes of 5 to 7 minutes left before we start a Q&A. Like Asami, you come a lot of, like your perspective comes a lot from also the adaptation part. You have a lot of experience. I think you described, Irina, less than, I would say, the model development team by itself, but more, the scenario creator, bringing it to use in the different governments. So what is your kind of challenges you see in the model adaptation?
Yes, thank you. We actually do develop models and tools. For example, our Flex tool, we developed that together with VTT, and the Splat model that we developed for Africa is developed by us. But we do collaborate with research organization. We are a small organization, and we cannot really have a capacity to develop tools fully fledged from scratch. Our experience is, so this question of the right level of complexity is something that we have been struggling. And we see that energy system will be increasingly relying on electricity, and the trend is digitalization and this decentralization. These trends are the trends that are not so friendly to the common way of energy systems modeling, because this development implies that demand and supply, the distinction between demand and supply is getting bluer and bluer. And the current way of doing demand first and then supply later may be a challenge. And also other challenge is about the demand. There was a question about the demand forecast and demand projections. And that's really something that has been under paid a little bit too less attention compared to the importance of that aspect. And the again, the right level of temporal and spatial resolution is very relevant because renewable energy has temporal and spatial element. But how can we balance all these details of operation into the in a balanced way in the long-term planning process that is balanced against the uncertainty? We are talking about 2050 energy systems. We think that there will be a lot of EVs, there will be a lot of decentralized energy electricity generation. How can we know that system would operate? And these are the areas that we would really like to see more research from the research community. And I'm really happy to see all these open source initiatives because this really allows the researchers collaborate together. And yeah, we really look forward to get good research coming out of this kind of community so that we can benefit.
Awesome, thanks, Sami. Then, like from this perspective, also, you know, just a little additional question. Like, what kind of role play people here?
The people in the open source community?
Yes, and especially also from the, I would say from the user side.
Yes. I mean, from the experience working with the government institutions, as Gerald mentioned, you know, like this kind of open source community would really give a great opportunity to create bottom up the whole education on the energy system modeling. It's not, we are working with the government, but the universities and research organizations are the source of the talent, and it's very important opportunity that this kind of open source community has. Maybe if I can say challenge would be that when we talk with the government officials or government researchers, Jared mentioned about the trusted commercial software. And there's an issue of trust, and really the quality control issue is something that many government institutions are concerned about. For example, when they would adopt any planning tool, they would really like to go to the software that has been proven, that has a proven successful applications. So in this context, as already previous speakers mentioned, it's very important to do the benchmarking activities, and that's really the key to develop the trust. Otherwise, it's going to be very difficult to for this open source tool to have to be used beyond the research community.
Yeah, like that's a great point. Benchmarking for trust. Thank you, Sami. Then Jared. So when you look, for example, 50 years ahead, what are the kind of opportunities you see in the field in terms of adaptation? What can we do better here?
Hopefully not 50 years ahead. I'll be very old by then. Hopefully sooner than that. But also, I don't necessarily have a crystal ball to tell the future. But I think, one thing that I would just mention here is around, I guess, improved communication and the ability to get across particular implications that are coming from various modeling efforts. So, number one, easy to use, quality and consistent post-processing of all of this information and data that's coming from various modeling efforts. visualizing them can be extremely powerful. And this is really critical. You can have exactly the same type of work being done, but if you can't visualize it and get the message across in a very brief moment of time, or the amount of time that a particular decision maker may have available for you, your analysis will be largely useless. And if you can't communicate that consistently and in the best manner possible, and proving this kind of track record on the basis of that messaging, we won't necessarily make the progress in terms of all of this modeling effort that's sitting underneath, and the complexity that as engineers and data scientists and the various contributors to these types of efforts are doing to try and hide that complexity will be largely ineffectual. So really trying to focus on getting that post-processing consistent, communicating it in the best manner possible, and also making sure that when those efforts are undertaken, and there's a lot of time and effort spent on it in terms of resources, making sure that it's updatable and reproducible. I know that that's a consistent finding, and I think across most of science is necessary, but in a lot of ways it's not necessarily possible, or hasn't necessarily been possible, not just within energy, but within other sectors as well. So trying to do that as much as possible, I think, is going to be critical to get that buy-in, even broader beyond that key sort of decision maker, and making that 5-minute elevator pitch, but also shifting it across to the broader sort of public discussion as to communicating the type of information that perhaps we think is quite important as modelers and people in this specific area.
And maybe here just adding, the last question in this context would be, is there actually also room for, new things? I think, like when we see the outputs, when we see the studies, they're usually kind of closed nature. So it's sometimes hard to reproduce things, official reports. Can we do there something in future, Jared? Opening this reports up, or is there any issue?
Yeah, I think making things machine readable, and when publishing studies, not just putting them into glossy PDFs, and actually having the data available is critically important that sits underneath it. And then of course you can put it into the pretty picture and the post-processed nice visualizations, whether that's sort of geospatial mapping or static graphs or dynamic graphs that you're going to be looking through as a policymaker or as a decision maker. It doesn't really matter, but as long as all that data is available, then someone else can take it and reproduce it in and of themselves as well. Yeah.
All right. There's great views from all the panelists. I think we're just opening up the Q&A. We have now about 10 minutes left for some questions from people. I see 2 raised hands. I'm just starting with them. Grammy, is that right? Just clicking to ask you to unmute yourself.
I'll try and switch my camera on. Yeah, thank you very much. This has been very, very interesting discussions, and I just wanted to support a couple of things that have been said. My background is system operations, and I've been involved in the power industry for many, many years. And of course, I know Jared very well, because I'm also from South Africa. But my particular challenge at the moment is postgraduate students and doing courses and that. And Clayton was right. We've got to move beyond every student having to build something from scratch. They need to do relevant research. And that's so important. And so when I heard about this, I'm very excited to try and get involved. I'm struggling, but Python, I didn't grow up in the Python age. I grew up in Fortran. So I'm trying to figure this out. But anyway, the students all know Python. So I think you're onto a very exciting thing. And I think the important issue around that is that if we can get the students excited, that builds the open source software. When they go to work, they take that with them. So that's the important thing that you're building up now, that when they go to work and they get given a commercial tool, at least they'll be able to use the tool because they know the software behind it. And they can use it, and they can trust the results. But also, more and more people using the tool will build results, will build trust in the results. And I know in my industry, there's people that are using it as well already to do small system studies and etc. Yeah, and Clayton, you're right. From a the system operations point of view, yeah, the system operators are going to challenge everything, but we can use these open source tools to put in new rules on that, which, you know, the commercial software, if I want a new rule put in, it's a whole long process. There's the open source. If I know the code, I can go and change the code. I can try a new rule. I can try a new, what happens if I put this extra dynamics of the planting? What happens if I show the first few seconds, or, you know, that all helps build up. And I just support you guys in what you're doing. And that's sorry, yeah, I won't ramble on anymore.
Like, awesome. I think that was less a question, but a lot of support. Thank you, Grammy. Thank you very much. Then we're moving on with the next question from Rudolf. I'm also asking now to unmute yourself.
Hi, can you hear me?
Yes, we can hear you.
Hi, so my name is Rudolf. I'm a research assistant from the Climate Compatible Growth Program. And it's not really a question, as more of a encouraging, sort of happy talk that I want to say, because having attended your talk just now and seen the type of work that you conduct at CCG, we do something very similar, and we're happy to see that the open space is really growing and is expanding into something a lot bigger, because you are right, and many of the comments that have been made, such as Grammy that made in terms of postgraduate students not necessarily having access to something that's already been built, or not having access to something that can be easily replicated. Well, CCG, we try to aim at that as well. We've provided 69 starter data kits for Africa, Asia, and they're open source, free, available. Anyone can go and use them. And similar to Grammy as well, actually, I know Jared myself too, because we hold an energy modeling platform for Africa, where we train some of the students on how to use different types of modeling tools. And I was training Jared actually for the osmosis, and it's really good to see him being involved in this as well, in the good spirit of keeping up the open source modeling tools and data, and sort of expanded that platform. So just to sum up, what I want to say is that I'm very happy to see that the open space is expanding. I'm very happy to see your involvement as well. Jared, happy to hear from you again once more. And yeah, well, I wish you the best of luck in all of this that's yet to come.
Awesome. Thanks, Rudolf, from the colleagues from CCG, Climate Compatible Growth. I hope also we find some ways to collaborate here and there. I think, you know, some of the data parts, we're working a lot on that as well. Hopefully we can establish this kind of connections to not duplicating some work. You know, maybe if it's out there, we don't need to work both on it. We just work on one of the packages, which is kind of our goals as well. Okay, then let's check some other questions. So there was a question previously asked about what is the reason of using top-down methods from Irakli. What is the reason for using top-down methods, approximating model parameters, instead of using bottom-up approaches and create models based on information from TSOs? Generally, this could be more error-prone solution. Yeah, Jared, do you have an idea on that, or a comment? Or probably it was also a question on us.
So I just wanted to confirm the comment was more around top-down models being more error-prone as opposed to bottom-up. Is that essentially the question, and saying, you know, is there a solution around that? I didn't see it in the text. So I'm just going to scroll.
Yeah, like I think that was the way, like, you know, why we use top-down, it's maybe less accurate than bottom-up modeling.
Yeah. Yeah, and look, I can just take some direct experience from South Africa, and what I've learned as well from colleagues that are working on exactly this within the national utility, at least from the ways in which I've interfaced with them, is bottom-up approaches, of course, are highly data intensive. I mean, you don't have a lot of that data. It's quite difficult then to make sure that those are as accurate. If you have all of the data, or you have a lot of data, or at least estimations of being at least close to it, then bottom-up methods can work really, really well. ESCOM specifically, in terms of their long-term energy forecasting, is using both sort of bottom-up, where the data is available as much as possible, but then almost sense checking from a top-down perspective as to what your energy demand forecast, for example, could then look like, and making sure that you are in the right ballpark at least, or within a certain level of uncertainty or band of uncertainty, and you're almost affirming both of the approaches. The reason, of course, using that top-down approach is that it would be less data intensive and you're getting to quite a similar answer. That's at least from my local experience and context that I've seen in South Africa. But more generally speaking, I wouldn't be able to speak for everyone, and more generally in terms of the different approaches either, but at least from a South African perspective, that's what I've seen, is that top-down was utilized because of the fact that you had limited data from using bottom-up type of methods.
And absolutely support here. Like we struggle actually to find bottom-up data, you know, like from small networks of houses. It's available here and there, but I think as Stephen, our colleague, introduced, we are actually working also on data-driven methods to at least approximate that where we don't have it available. And hopefully the situation will improve, and we can even benchmark and see how well this approximation suits in the different areas. All right, so no raised hands, but I think we have plenty of questions, which is kind of tricky to find out which one is not answered yet.
I've been following the chat a little bit. Yeah. There's another one from Irkal about the complexity is increasing significantly, and the question about using linear methods versus more complicated methods, and whether it's possible that a simulation approach may be a substitute for optimization in some context to address complexity, basically. I should have just read that verbatim, but I tried to paraphrase and ended up with a longer. And so I was just going to say that, I think there are cases where simulation is sometimes a good solution. But I will also, I am a optimization person in many respects, and I think there are a lot of techniques that are emerging and yet to be applied to some of these problems in the optimization space, and there's a lot of power there. So I think there's a little bit of both. There's a lot of opportunity for machine learning type approaches, which kind of use simulation to find optimal solutions, or maybe not provably optimal solutions, but in most cases we don't care. We just want something better than what we know about today. And so yeah, I do think there's a lot of opportunity for that. And yeah, so I'll leave it there, but I won't say that there's a best approach.
All right. I think that's pretty clear. I would say checking our time schedule. Maybe you have other meetings afterwards. I would say we are just stopping this session here now. Thank you again to all the panelists. It was super exciting to learn from your perspectives. Just to summarize, like we were talking about kind of challenges of the usefulness in open space, and also I think through the questions also in the, let's say, in the closed source space. There are many more features which probably can be added. New data can be streamlined into the models, and things need to change for that. On all of the things from the opportunity side, we can work on them, both, I think, in open and closed source tools. Clayton, you mentioned something about mistrust. We have a lot of mistrust in this tools that maybe not including all the physics in the modeling part, and building trust is one of the part, also in terms of adaptation and all these parts which we need to work on in the future. And how we can build trust is probably on one side through the benchmarks, where we're currently working on benchmarking again closed models, as Jared said, against other open source models, and that's how we can build trust. And yeah, then maybe not on the last point, we heard also that there's a need to work together, so that every institution work on their own model, or every grad student is maybe hopefully soon a kind of future. I mean, sometimes it's also interesting to revise topics, duplicate things, and maybe to find something new. But we hope really that for the future opportunities that people decide to join rather also like established tools, be it Panda Power or anything else, be it PyPSA or power models. There are a lot of opportunities. So just have a look around, compare them, understand them, and that's the first step. Understand, and then you climb the ladder, and then you see where you go. All right, and with these words, I'm just ending the session now, and I'm staying actually here until the end, but you can leave now if you like. So have a great morning, evening, or lunchtime, wherever you are. See you. Bye-bye.